have some new vocabulary. We have trapezoid, which is a quadrilateral with exactly one pair of parallel sides. We have the bases, which are the parallel sides. We have the legs, which are the non-parallel sides. We have the base angles. And then we have what's called an isosceles trapezoid, which has congruent non-parallel sides. And then we have what's called a median, and I'll show you pictures of all these in just a sec. All right, we have each pair of base angles of an isosceles trapezoid are congruent. Okay, so if we're talking about an isosceles trapezoid, that's this picture right here. These two angles are congruent, and these two angles are congruent to each other, but not to each other this way. Okay. If we take an isosceles trapezoid and we draw the diagonals in, so I'm going to do that over here, I think. Okay, so I have a trapezoid. Let's say it's isosceles. The diagonals will be congruent to each other. So if this was trapezoid ABCD, AC will be congruent to BD. And then we have a median of a trapezoid is parallel to the bases, and its length is 1/2 of the sum of the bases. So here's our median here. I'm going to highlight it. That's our median right there. Okay, so the length of this median is 1/2 adding the two bases together. So 1/2 BC plus AD. This is the formula for the length of a median. Okay. And we know it's a median because it'll hit the midpoint and you'll have this where the two parts here and the two parts here are the same length. All right, so we have LMNO is our trapezoid, and our median is here PQ. LM, this whole length here, is 8. I want to find this length right here, PM. It'll be 4, yeah, because it's 1/2, because it's a median, midpoint. Okay, so here we have median is EF, so that tells me this is this is this, and I know it's an isosceles trapezoid, so actually these lengths will be the same also, because this whole length is the same as this whole length. Because it's an isosceles trapezoid, I also know that this angle is the same as this angle, and this angle is the same as this angle. Okay, so if BC, that's this whole length here, is 34, FC will be 1/2 of that, so 17. We'll just divide by 2. Okay. ADC, that's this angle here, is 59. BCD is going to also be 59 because it's an isosceles. Okay. AB is 16, DC is 24, and I want to find the length of the median. So I'm going to do 1/2 of 16 plus 24. So 1/2 of 40 is equal to 20. Okay, so far okay? And then DAB is 109. I want to find DEF. Now, I did not give you guys a theorem for this, but if this whole thing is a trapezoid, what is this shape right here? Okay, and these are parallel lines. And remember what happens when we intersect parallel lines between this angle and this angle? They're corresponding in the same position. So it's the same angle. So what we could do theoretically when you have that median is go ahead and label these the same and those the same. So you get, when you have an isosceles trapezoid, you get with a median, you get 4 angles that are all the same, and then another set of 4 angles that are all the same. Good? And then, technically I could find the midpoint here and find another median on here, and it would keep adding. I could keep finding medians and medians and medians until it got to be to the point where it was too small for me to write them in, but they'd still be there. And I could keep adding congruent angles that way. Midsegment. When we get into the midsegment of a triangle, it's the same thing as a midsegment of a trapezoid in that it's joining at the midpoint of the 2 opposite sides of the triangle. Okay? And then the length of the midsegment is half of the length of the side that it's parallel to. Right? So here's the midsegment. Here's the side that it's parallel to. So it'll be half of that length. Every triangle has 3 midsegments. Oh my gosh. Okay, well, just do that one. Okay, if I come in and I have a triangle, I have a midsegment here between these 2 midpoints. I have a midsegment here and a midsegment here. Yeah, it makes a triangle inside of our triangle and actually makes 4 triangles. This length will be half of this length, which means it's equal to those 2 because the midsegment is half. So these 3 lengths will all be the same. This length will be the same as these 2 lengths, which is half of the total. And this length will be the same as these 2 lengths. So it's kind of when you put midsegments into a triangle, you get a bunch of parts that are the same length. If that makes sense. And look at what you kind of create is you create 4 triangles that are proportional to the original big triangle. Shrunk down by half. Have our midsegment theorem. We have UV is 11. So that's the whole length. So what's XV? Yeah, so half of it, so 5.5 or 5.5, however you want to say that. Okay, not too bad. Okay, now we have triangle ABC. AC is 12, so what's DE? DE is going to be half the length of AC. 6, yeah. So what will happen is if this length will be the same as that one, this length will be the same as this one, and this is half of that. Okay, AD is 5. That's this part here. What's the whole thing? A lot. Okay. Yeah, so AD is 5. This part, so the whole thing is 10. DE is 14. So what's this part? 14 times 2, 28. And then just because I'm evil, we threw some algebra in. Actually, I didn't write this, but okay, BC, that's this whole thing right here, is 4x minus 2. EC, that's this length right here, is 3x plus 1. Well, no.
So would that be 2 times 4x minus 2?
Not 2 times 4x minus 2. 2 times 3x plus 1, yeah. Because we have to have 2 of these to make this whole thing. Okay, this part, 3x minus 1, then that makes this part also 3x, or sorry, plus 1, 3x plus 1. Because these two lengths are equal because of the midsegment.
So what else do you for BC or
The same for BE. And then we want to find, and then the whole thing is 4x minus 2. So 2 of these equals 1 of these. So 2 of those equals 1 of those. So I'm going to distribute my 2. Okay. Subtract 4x from both sides, and I get 2x plus 2 equals negative 2. Subtract 2 from both sides, and I get 2x is equal to negative 4. Then divide by 2, and I get that x is equal to negative 2.